Okay, so for our fifth proof, we have here a quadrilateral is a parallelogram if a pair of its opposite sides is parallel and congruent. Okay, so we have here, okay, so quadrilateral RFTS with RF, okay, RF and ST being congruent, okay, and RF and ST are also parallel to each other. Okay, so you want to prove that quadrilateral RFTS is a parallelogram using, okay, so a quadrilateral is a parallelogram if a pair of its opposite sides is parallel and congruent. So that's proof 5. Okay, so let's go right ahead. So this is our figure that we have here, and of course for our 2-column proof, we're going to start with our given. Okay, so for our given, we have here RF and ST congruent. Okay, so we have here line segments RF. Okay, so let's just write that neatly. Okay, so RF and ST. RF and ST are congruent. Also, we have here RF is also parallel and congruent and parallel to each other. Okay, so those are given. So let's write that given. Okay, so what do you think, guys, could be our second statement here? You know, to prove that this to prove our fifth property. Okay. Okay, so we can try to draw a line segment here between F and S. Okay, so let's try to draw a line segment between those, and let's write that on our statement. Draw diagonal FS, and the reason for that will be 2 distinct points determine a line. Okay, so after drawing a diagonal on this parallelogram RFTS, so we have drawn a diagonal FS, we can name some angles here: angle 1, angle 2, angle 3, and angle 4. And therefore on our third statement, we can state, okay, we can state on our third statement that angles 1 and 2 are congruent. Okay, so the reason for that is alternate interior angles are congruent. Okay, and also after drawing diagonal FS, we can say that if for our fourth statement, okay, for our fourth statement, we can say that FS is congruent to FS through the reflexive property of congruence. Okay, so the triangle congruence postulate that we're leading here, or we're trying to lead here, is for the SAS, triangle congruence postulate. So as you can see here, so now we can say that triangles are FS and STF are congruent to each other through the none other than the side angle side, or the side SAS, or side angle side, or SAS triangle congruence postulate. After stating that, we can also say that angles 3, okay, so we can also state, okay, so we can also state that angles 3 and 4 are congruent. Okay, so they're congruent because of CP-CTC. Okay, so we already have 2 congruent triangles here on our figure. So we have angles 3 and angles 4 are congruent through the proof CP-CTC, or the corresponding parts of congruent triangles are congruent. Okay. Then for our seventh statement, we can say that RS, okay, RS is parallel to FT. And the reason for that also is because, if you notice, it's also a pair of parallel lines that when cut by transversal, you get 2 congruent alternate interior angles, which is angles 3 and angle 4. So let's write that if a pair of parallel lines is cut by a transversal, which in this case in our parallelogram is a diagonal, therefore their alternate interior angles are congruent. Okay, so let's write that. Okay, and lastly, for our 8th statement, we can finally say, okay, that we have here, okay, number 8, quadrilateral, okay, let's spell that, quadrilateral RTS FTS is a parallelogram, so we can confidently say that it's a parallelogram through the definition of a parallelogram, because we've already seen that for both pairs of parallel sides there are congruent alternate interior angles, and that's how we do our proof for this fifth problem, that quadrilateral is a parallelogram if a pair of opposite sides is parallel and congruent. And we've proven that RS and FT are congruent and parallel, and therefore this figure must be a parallelogram. Okay, so for the last property of a parallelogram, we have here the diagonals of a parallelogram bisect each other. So this is the sixth property of a parallelogram that we're trying to prove using a two-column proof. Okay, with another proofs we used a paragraph proof, but for here we're going to use a two-column proof. So given parallelogram EQGD, so we need to prove that EG, okay, line segment EG and QD, so those are two diagonals. Diagonals bisect each other at point B. Okay, so we have to prove that. So the main plan is we have to use the ASA congruence postulate and the CPCTC to conclude that the corresponding parts of these two congruent triangles, EG and QD, are congruent, and therefore they must bisect each other. Okay, so let's try that. Okay, so we have here for our first one, for our first statement, our given is that parallelogram is that EQGD, this figure right here is a parallelogram, and that's a given. Okay, so let's write that. Okay, so that's a given. And after writing our given, we can state that EQ and DG are parallel to each other. So that's the second statement. So EQ and DG are parallel to each other. So the statement for that is, or the reason or proof for that is a definition of a parallelogram, because we have two pairs of parallel sides, congruent and parallel sides for a parallelogram. Okay, and for our third statement, we can say that angles. Okay, for our third statement, for our third statement right here, we can say that that angles, we can say that angles 1 and 4 are congruent, and also angles 2 and 3 are congruent, because in a pair of parallel lines there are congruent alternate interior angles. Okay, so let's write that proof here. Okay, so there you go. Okay, so let's make this a bit smaller. Okay, so there you go. Okay, for the fourth proof, so for the fourth statement, we can say that ED is congruent to QG. So that's because they are congruent. Those two sides are congruent because in a parallelogram, the opposite sides are parallel and congruent. Okay, so they are congruent. Okay, so that's for statement number 4. And therefore, for our fifth statement, we can say that triangles EBD and QBG are congruent. Okay, so how can we say that? That's through the angle side angle, to the angle side angle, or through the ASA triangle congruence postulate. Okay, so let's write that. Okay, so we can say that those two triangles are congruent through the ASA or the ASA triangle congruence postulate, since angle 2 is congruent to angle 3, angle 1 is congruent to angle 4, and ET is congruent to QG. So for our sixth statement, we can say here, so since the two triangles we've already established that the two triangles are congruent, we can say here on our sixth statement using CPCTC that DB and BQ are congruent, and also EB and BG are congruent. And the reason for that, of course, is the CPCTC, or the corresponding parts of congruent triangles are congruent. And lastly, we can say for our seventh statement, we can prove now that EG and QD bisect each other at point B. Okay, so let's write that. So EG and QD, those diagonals bisect each other at point B because of statement 6. Okay, from statement 6, okay, so we can say there that's the definition of a bisector. Because we've already seen that DB and BQ are congruent, the parts of the bisector DQ, and EB and BG are congruent, which are parts of the diagonal EG. Okay, so therefore, from statement 6, we have here the definition of a bisector, and therefore we've proven that the final property of a parallelogram is true. The diagonal of a parallelogram bisect each other. Okay, so now we're on to solving problems involving parallelograms and diagonals. So we have here our first problem. Dr. Ina Montero wants to determine the angle measurements of her new parallelogram-shaped cafe. The basic floor plan of the cafe is given here on the right, with vertices R, H, A, E. Find the value of A and the value of the three angles on the given figure. So we have here, guys, the two angles, 7A plus 1 and A plus 37. And we all know, guys, that the opposite angles, okay, the opposite angles of a parallelogram are congruent. So therefore, we can say that angle R is congruent to angle A. So we've already proven that also on our previous proofs. Okay, so therefore, we can say that 7A plus 1, okay, 7A plus 1 is equal to A plus 37. Okay, so that's equal because the measurement of angle R is equal to the measurement of angle A. Therefore, we can do a transposition or the addition property of equality. So this is going to be, or the subtraction, so this is going to be 7A minus A is equal to 37, okay, plus 1, so this is going to be minus 1. It's going to be 6A is going to be equal to 36, and therefore the value of our A is going to be equal to 6. Okay. After this, guys, we can now solve for the value of the angles. Okay, so we have here angle R is equal to 7 times 6 plus 1. Okay, so that's going to be equal to 43 degrees. Okay, we also have here angle E is equal to 6 plus 131. So that's going to be 137 degrees. And also we have here angle A, which is equal to 6 plus 37. So that's equals to 43 degrees.